Hello there, thank you for joining me again today. We're going to have a look at the quality of Chinese plugs and connectors that I have with me today to show you. This is part 2 of a series of videos which talks about microwave radio frequency connectors and plugs. And if you haven't seen part 1, then please do go to the playlist section on my channel, where I've linked all the videos together for you to make it easier to find. But in part 1 we connected the frequency standards, the fixed loads rather, open and short, and we calibrated the vector network analyzer using a special standard, a load which has been specially manufactured to high frequency up to 20 gigahertz, as well as a specialist Anritsu calibration standard. And what we've done there is we've calibrated the vector network analyzer in preparation for making a measurement with some of these RF plugs from China. Now with me today I've got a couple of sample ones here. These two are come from China, and to look at them, they look really good quality, you know. I mean, you can't really tell, you know, if there's anything structurally wrong with them. They seem okay, and they look well made. They're quite heavy, you know. They've gone to great extent to make them the best quality that, you know, you can see that they are pretty good. Likewise with this one, this is a BNC to N-type female, so BNC female to N-type female, and this is a BNC male to N-type female. Now when we buy these connectors, often we don't worry about whether or not they're going to handle the frequencies, and that they're going to be structurally sound, and that they're worthy of the price that we pay for them, which is generally quite cheap if they come from China. And there's a reason for that, and that's what I'm going to show you now in this video. Now we had the vector network analyzer connected up so that we had in part 1 a calibrated load, which then put the impedance, the dot if you like, smack bang right there in the middle at 50 ohms, and it was just a single dot right there. Now when I connect this in line with a 50 ohm load, we're going to sweep this right up to 20 gigahertz. Now obviously it's not designed to go up to 20 gigahertz, but it's just an example showing you what kind of RF performance that we're going to get out of these, even in the frequency bands that they're intended for, like from DC to 1 gigahertz for example. And the beauty of this instrument is that we can analyse that information even in the frequency bands that they're meant to work in, such as between DC and 1 gigahertz. Now different types of RF connectors and qualities, and the 3 different classifications, which are generally instrument grade, research grade, and millimetric grade. Those types of connectors are all varying qualities, which we're going to look at shortly. But these particular connectors are just general use, DC to a gigahertz, typically quoted in websites and things, such as, you know, AliExpress, Amazon, that kind of thing. Generally where some of the Chinese stuff sold. So what we've got, we're going to connect this up to this 50 ohm load that we had in part 1. As I say, if you haven't seen the part 1 video, please do go back and have a look at the part 1 video, simply because in the part 1 we showed the, if you like, the analyzer connected up to this little 50 ohm load, which this is a specially made 50 ohm load that goes up to 20 gigahertz, and it's made by Anritsu, so it's a very high quality calibration standard. Now when we connect this up to the end of the connector, which we've calibrated it against, and again this is another feature of Chinese products, some of these connectors, the thread's not really making on that, it's just turning round and round and round, and it comes apart, you see, as well. That's another thing about some of these cheap Chinese connectors already. This is something I wanted to show you a bit later because I knew it comes apart, but I didn't want it to come apart right now so early in the video. But we may as well show you just for the sheer fun of it. But what you'll find with a lot of these Chinese connectors is the threads that are on the outside of the connector are not machined correctly, and they don't mate properly with legitimate, like this is a Radiall connector, a high quality one, very expensive, and the threads that are in these are proper and it's made to the correct tolerances and manufacturing standards for high precision RF connectors, whereas this is just, you know, generic. It looks the part, but it isn't the part. It's all, as what we say in the industry, fur coat, no knickers. And this particular connector can actually cause damage to a legitimate good quality connector like this, simply because it's not machined right, is the threads. But as well as that, the actual construction of the connector, as you can see there, fails miserably because it shouldn't come apart. None of the connectors that are good quality, which you'll see shortly from the samples that I have, ever do that. It's only the Chinese connectors that I've found that drop apart like this. So what we'll do, we'll reconnect on, and we'll try again, see whether we can connect the 50 ohm load to it. Hopefully this time it'll allow us to do that. So if you just bear with me a second while I connect it up. Okay, right, we've got it connected now. It's all pushed on correctly and nicely connected with the termination load at the end. Now if we have a look here, this is a horrible mess that you get with a lot of these Chinese plugs. Because of the materials that they use in the construction of these plugs, the qualities of the metals and the alloys, and the fact that a lot of the alloys are cheap, rubbish, recycled alloys that are re-sprayed or painted to make it look like they've got chrome. The inner conductors themselves are not brass with gold plating. They're very low quality. They don't even employ beryllium copper either. That's something else which, you know, you'll find on a lot of very high quality connectors made by Greenpar, Selectro, Radiall, Amphenol, and many other manufacturers which I'll go into shortly. They manufacture these connectors for a reason to such high standards, so that they'll work to very high frequencies and very high RF power tolerances. Now at the moment we are scanning from effectively sweeping the frequency of 250 megahertz to 20 gigahertz, and at the moment at those frequencies, at the moment, even at the low frequencies which this connector is meant to work at, obviously we've got the marker which is highlighted as that little marker there is 1 at 250 megahertz at the moment. And if we look up here in that corner, we've got a very strange impedance at that frequency which shouldn't be there. Now if I push on the connector like that, I'm putting physical force on it, shoving towards the test set, you can see it's going up to nearly 50 ohms in the top left hand corner. It says 47.89, and that's because you've got to put physical force on it. And again, just moving the connector about, just doing that with your fingers causes mass changes in its performance. And again, as you can see in the top left, we're not at 50 ohms, we're nearly at 50 ohms, but we're not at 50 ohms. Now if I move the marker, so we'll just switch that off for a second so we get a better picture. If you keep your eye in the middle of the screen at the bottom, as I move the markers, you'll be able to see that at 1 gigahertz, for example, I'll just get it round about the 1 gigahertz mark, its impedance is actually 50 ohms, but obviously even when we come down in frequency, again at 250 megahertz it's 47 ohms, and then you know the lowest frequency there, its impedance is quite wild, up to a gigahertz, and then that's 2 gigahertz. So if you were trying to use this at 23 centimeters, for example, it's 29 ohms now, the impedance, and then at 2 gigahertz, 2.2 gigahertz, it's 52. So it's all over the place, you know, and as we go up the frequency ranges, 5 gigahertz, it's way off the mark. And of course all these can be changed by moving the connector or putting pressure on it, which this shouldn't happen. You see, it's creating all sorts of phase noises and issues. And that's the thing with these connectors, you know, the poor quality, they come apart, and generally speaking, you know, you end up disappointed at the end of the day because you paid money out for plugs and connectors which you believe to be a good standard and good working capability, and they're rubbish, absolute rubbish. And most people that don't have this kind of test gear or are not really into RF into a deep level won't realise that, you know, if they've got a linear amplifier that's doing say 400 or 500 watts on 2 meter amateur band, and you've got this connector to connect between say a BNC and an N-type, you're going to get a lot of problems with your RF. You know, it's going to cause heating, RF heating in this. It's going to not perform electrically correctly at RF frequencies, and especially when you put a lot of power through it, RF power, it'll fail quite miserably. And not only that, the fact that it physically comes apart, which it shouldn't do, is another sign of the poor quality nature of it. And it's the same with this one. This one looks alright as well, but it actually comes apart, does this. And again, you know, if you were to try and connect this up as well to the same analyzer, then you know you end up having the same problem. And it's just one of those things where you know you will come across these connectors, you know, where they will fail on you, I'm afraid, and that's just the way it is. And again, the pin's dropped out, it's low quality rubbish, and I'll just put this down a second while I pull it out. So there we are, that comes out there. Again, that's on the with a BNC thing I plugged onto it as well, just so I could pull it out. But as you can see, you know, any just general connecting a cable, it's always difficult to show these things with one hand, but when you were trying to connect a cable to this, and the exertion, the forces that you put on it to switch the locking nut on there, it will pull it apart. You know, again, total rubbish, absolute crap from China, I'm afraid. And you'll find this a lot with RF plugs and connectors. So what I wanted to show you was some of the common problems that you get with some of these RF plugs. Is, for example, if you buy a socket like this for a project or whatever that you're going to do, you'll find that a lot of the Chinese plugs, they don't have PTFE. So when you apply your soldering iron to the contact down there, and obviously this PTFE shouldn't melt if it's PTFE, and you'll find a lot of the Chinese ones they do, it melts. So this pin starts moving, going off at an angle skew, if it all melts inside, and then the connector's, you know, totally useless. And it's again the same with other RF plugs. This is a Pro Signal, another good quality connector, an N-type male plug, and again the Chinese ones just are awful that I've come across, where, you know, the insulators inside and things melt. The threads are not machined right, so they won't screw on properly, or they'll strip the threads. There's all kinds of issues that you get. So I just wanted to go over a couple of really good quality connectors that you can look out for. Some of the best quality connectors that there are around are from companies like these. This is called ITT Canon or Selectro, and a lot of these businesses are all sort of merged now. Like for example, There's companies called Radiall, which I'll show you in a moment, which became Radiall in France. Greenpar, there's Pro Signal, Amphenol, Radio. Obviously, there are many other manufacturers which I'll show you shortly, which manufacture superb quality connectors, and it's always worth paying the extra to get these kind of connectors and plugs, because they'll last a long time but they'll perform correctly, which is something that you don't get with the Chinese adapters and plugs. So if you're buying RF plugs, adapters such as these, you know, go pay extra, get decent quality ones, because the other types of connectors, although they look the part, as I say, they're all fur coat, no knickers. The trouble is that, you know, you're buying what you think's good quality, and it looks the part physically, but electrically it's crap. So this is a gold plated connector by a company called Selectro. Radio, they do BNC plugs and things as well, and Greenpar. MaCom, that's another manufacturer that's really good. Again, these are SMA. There's a lot of cheap SMA plugs out there as well that come out of China. So pay the extra. You know, there are suppliers out there on eBay and other marketing sites that do sell bagged Selectro RF plugs and connectors. Andrew is another manufacturer. They tend to make a lot of the connectors and plugs which go on radio mass hilltop site feeders, and they obviously are larger, many of them, and there are copies out there as well, so be careful. This is another example of Greenpar, and what you'll find is with a lot of the genuine RF products such as Greenpar or Radiall, they'll actually print the part number on the connector itself, or there'll be some marking on there, and that's another good sign, and they'll have a part number, and again, you know, very good quality British made or American made plugs. Excuse me. This is another one, again, very good quality PTFE, nickel plated brass, gold connector, gold pins, you know, 50 ohm plugs, good quality RF connectors. You know, again, it's worth paying the extra, you know, don't be cheap. And there's gold plated variants as well for the microwave frequencies. And again, another example of a Greenpar plug or connector. You can really tell the quality. It's not until you've had the rubbish do you really see what the quality can give you. And these will last for years. I mean, I've got some of these plugs that are nearly 20-30 years old and they're still like new looking, and they're brilliant, you know, and it's worth looking out for these. There's so many different things. Again, there's another company that does superb Radiall connectors, and again, you know, we're talking the creme de la creme of RF plugs, very, very well made to military spec, and often they are used on things like military applications as well. And again, another example of a MaCom or a Greenpar RF socket, and they're made to proper tolerances and specification, and they'll last, you know, for decades. And this is another good company called Allied, and they make plugs and connectors as well. This is an N-type female coaxial one, and again, you know, these were made to superb standards and tolerances. Even British company again, RS Components, still good. You know, this is quite an old part now, for going on for a few years, 10-20 years maybe, but again, worth having, you know, made in the UK. These are often made by Greenpar, and the way you can tell that, if you look at the bag and compare it to a Greenpar bag, you've got the blue spot, so Greenpar have made that for RS Components. So that's a little rundown, but as you can see, you know, keep good RF connectors and they'll last you a long time. And you know, don't buy the rubbish. Buy good RF plugs and connectors. And if you buy good RF plugs and connectors, they'll look after you. And you make good cables with them, coaxial cables, which is another video I shall go into about coaxial cables. But BNCs, and you know, there's a lot of the really good quality ones. I've got the gold pins as well, and you can probably see that in there. This is a Hills product, I think, but again, the gold pins, and these are all very important for the electrical characteristics of RF plugs and connectors. And again, there's quite a lot of other rubbish out there from China which you've got to be careful about in the RF world, and that's things like, you know, RF attenuators as well. If you're using RF attenuators, and these can often be copied. Mini circuits manufacture RF attenuators, NADA, microwave, Marconi, Aeroflex, you know, I've got plenty of these, and these are very expensive, but there are Chinese copies out there, so you've got to be careful, and they're cheap for a reason. That's what you've got to ask yourself when you see these RF plugs and connectors. I'm not saying that everybody who sells RF plugs and connectors, if they sell them cheaply, the copies or anything, but a lot of these sites like Amazon and AliExpress and that, you know, they are coming from China, and you can tell that due to the lead times that it takes and the cheap price. So be careful. Andrew connectors, Greenpar, MaCom, ITT Selectro, there's all sorts of different really good quality connectors. Radiall of France, for example. Look out for them because they are the best quality, and if you can get them, buy them, because they will last you a long time, and you'll never have any problems with connections, RF power problems with amplifiers. You know, I mean, if you're building an RF amplifier, you know, and you're putting N-type sockets on, you don't want crappy Chinese ones that melt and are no good at those sort of power levels and frequencies. And there's a reason why, as I say, that you should buy better quality connectors, because with RF, you know, the slightest metallurgy problems or corrosion and lack of proper insulation properties will mean that it affects the frequency response of the component and how it works. So beware of that, you know, when you're choosing an RF plug or a connector. And always try and buy the best ones if you can afford it, but you live and learn by experience. That's what I find. So thank you for watching the video. I'll come back in another video regards to the RF plugs and connectors, agendas, the types, the qualities, the differences between the instrument grade, millimetric, and obviously microwave RF plugs and connectors, and we'll discuss more on the subject. So thank you for watching, and see you in the next part.